Hello everyone, Dash here, DMD of Houston Institute here for the fifth and final installment of the Houston Institute Data Series. In the first four videos, we talked about scoring exam data, breaking down exam data by standard, tracking student growth, then we went off that beaten path a little bit and talked about non-academic and non-testing data. And today what we're talking about is more advanced topics talking about that same testing data. So what I really recommend is that even though all these videos technically are beginning level videos with Google Sheets and Google Systems, I'd really recommend if you haven't had a lot of experience with spreadsheets, with Excel, with Google Sheets and those kinds of systems, really watching videos 1 through 3 first. The links will be in the description of this video to get some familiarity and do those exercises before we go on to today's video. If you have any questions, please feel free to email me at this email displayed. The data used in this video can be found here. Just type this into your browser or click this link in the description, and it'll take you to the data to download. So we're here, we've typed in the tiny URL, and we've gotten here to the data. As always, we have to make a copy of this, make sure you're signed into your Google account, and then File, make a copy. Go ahead and add it to your drive. Now, we're working with our endpoint from video 3. We have a class of 20 students who happen to be the Los Angeles Dodgers, best team in the major leagues. And we have one test from them on the first sheet. And the second tab down here, we have the overall scores on different assessments over time. Now, what I want to do in a more advanced topic is talk about how can we standardize these scores? How can we put these scores on a similar scale so that we could curve their tests and give them all fair grades, and also at the same time measure their growth in a really rigorous way? Because I had a formula for growth before, but it was a little bit arbitrary. It had some logic to it, but it was a little coarse, a little bit rough. Let's talk about how we can do that in a more systematic way. So first, let's go to the first tab, the pre-response exam tab. And we found that the average percent correct on that exam down here was a 56.63%, so about 57%. Not an amazing score. However, I do teach AP classes, I teach IB classes, and for instance, for AP Stats exam, if you get 56% right, that's actually not bad. That could be a 3, maybe even as high as a 4 if it's a tough exam year. And if you want to make grades for your class that take that into account, that it is a tough exam and that 50% sometimes can be passing at that level, you want to make sure that your grading system has a curve to it. Here's one way to do that curve. So I'm going to click up here in L3, and I'm going to type into the formula bar equals, and I'm going to get the percent he got right. And I'm going to subtract from it the total average percent for the whole class, which again was 56.63. So I'm just going to round that to 0.57. So what this formula will tell me, and I haven't clicked enter yet, so I haven't gotten it yet, that will tell me how different he was from the average performance of his classmates. If that number turns out to be positive, that means that he did a certain percentage better than his classmates. If that number turns out to be negative, it means he did a certain percentage worse than his classmates. So I'll go ahead and press enter. And he scored 31.46% higher than the average percent among the area students. But there's one thing to keep in mind here, which is, what about the variability in this data? We could have a test where almost every student gets a 56%. And so scoring an 88%, 31 points higher, would be an incredibly good score. If everyone got 56% or lower or somewhere around there, and you got an 88%, that's amazing. Whereas here it looks like there's a lot of variation. Some students got a 15, some got a 25, one student got 100. So an 80%, while it's good and definitely better than the average, it's not an amazing, blow you away kind of scores. We need to take that variability into account. So I'm going to click back on that cell, back into L3. I'm going to modify this formula. So I'm going to go up to the formula bar. I'm going to put, after the equal sign, an open parentheses and close parentheses around what we've written. And then I'm going to divide it by a number that measures the variability of our data. So one way to measure the variability is to get the standard deviation. So a statistical measure of the typical deviation from the mean in our data. So I'm going to type in after that division sign, STDEV, which is standard deviation, open parentheses, and then I'll highlight all of our scores here and close parentheses. Now, one important thing, make sure to put money signs, I know it's kind of funny, money signs next to each part of K3 through K22. What that's going to do is it's going to make it so that when we drag down this formula for all the students, the money signs hold in place that we're calculating the K column and we're calculating between 3 and 22. And that when we drag it down, the standard deviation is going to be constant. So as we go down, it won't move those cells down the page for standard deviation. It's going to say, all right, we're still getting a standard deviation of Pedro Baez to Alex Verdugo. So I'm going to click enter. I got this number right here, 1.22 about. That means that he was 1.22 standard deviations above the mean. So I'm going to drag this down. And we see here a range of scores, 1.22 above the mean, 1.6 standard deviations below the mean, 1.7 standard deviations above the mean, etc. Usually, statistically speaking, more than 2 standard deviations above the mean, you're starting to get like really, really good score. You're starting to be more of an outlier in a good way. More than 2 standard deviations below the mean, you're starting to be more of an outlier in a bad way. So now the question is, how can we curve these scores in a gradebook? So I'm going to delete this part right here, and we're going to talk about how to curve these scores. All right, so to curve these scores, first I need to think about, as an instructor, the mean score. Say someone got a 57%, right around the mean. What grade should that get? Well, for an AP exam, 57% is actually pretty good. I might round that to, like, say, an 80. So I want, if someone gets the mean score, they should get an 80. So what we're going to do here is in the M column, I'm going to type equals, and I'm going to put that mean score that I want to reward them, which is an 80%. So I'm going to put 0.8, 0.8 plus, and then we're going to get their number of standard deviations above or below the mean. So for Pedro Baez, that was 1.22 standard deviations above the mean. So you 0.8 plus that times, and now this is another choice point you're going to have to make. So for example, 1 standard deviation above and below the mean in a normal curve contains about 68% of your data, a good majority of your data. So if I'm curving the true middle to an 80%, then if I get someone who scores 1 standard deviation above, they should be significantly above an 80%, but still within a reasonable range. Maybe they would be at a 90%, maybe they got at 10 points. That's a choice point for you to make. All this strategy I'm giving you is only one way to curve a test. This isn't the normal standard way that everyone uses. I'm just giving you one method to take you through the logic of how curving works. So I'm going to multiply by 0.1 because I want them to move up 10% if they get 1 standard deviation above the mean, or go down 10% if they get 1 standard deviation below the mean. So I'm going to do it times 0.1. Press enter, and we can see that, oh, we got a cat here. Hey, kitty. We can see here that Pedro Baez's score is a 92% in the gradebook. I'm going to go ahead and click format on that and make it go from a number into a percent again. And I'm going to drag down that formula. So you see here the student who scored just a 15% now gets a 63 in the gradebook, a failing grade, but it's not going to wreck them like a 15% would, where maybe they feel like they wouldn't be able to recover for the semester and they would stop trying. The 100% for Cody Bellinger becomes a 96%, 97%, so they feel like they could still improve. The 34%, although it is a fair amount below the mean, it's less than a standard deviation below the mean, so they still get a 71. And 34% is a place, say on the AP Stats exam, where you're definitely not passing at that point, but you're still within a range of where you can still shoot to pass the exam if you were to improve your score a bit over the course of the year. So you don't want to wreck their grade, maybe still give them a passing line because there was some evidence that they studied, but go from there. So that's it. That's the advanced topic. And I hope you've really enjoyed this Houston Institute data series. I know I've enjoyed filming it. Again, any questions, feel free to reach out to me at the email in the description of this video.